we have these points on our unit circle. We call them X and Y. So if we have our circle, we have whatever this point is, we have an X value and a Y value. On my unit circle, I'm going to say only on the unit circle, because if it's not on the unit circle, we have a little bit different thing we have to do. But as long as we're talking about the unit circle, my cosine is always my X value. My sine is always my Y value. And then the tangent is the same as Y over X. Often we call this sine over cosine. For example, if I know this point out here, let's say it's the square root of 3 over 2 comma 1/2. I would know that my cosine, I have to call this theta. My cosine of theta is going to be the square root of 3 over 2. My sine of theta is going to be 1/2. My tangent of theta is going to be the sine over the cosine, so 1/2 over the square root of 3 over 2, which is equal to 1 over the square root of 3. If I rationalize this, it becomes the square root of 3 over 3. So those are my main functions. Then we have secant, cosecant, cotangent, which are literally just the reciprocal. The reciprocal of cosine is secant. And all I did is say it's 1 over X. So the sine is the cosecant. So this is secant. And this is cosecant. So the cosecant is 1 over the sine. And how I kind of remember it, I don't know if this helps anybody, but I kind of give clues about how to remember things. I always feel like the cosine and the cosecant should go together, but they don't. So you kind of have to switch them. So cosine goes with secant, and secant and sine goes with cosecant, and tangent goes with tangent. These are just reciprocal. So for example, here, if I wanted to know what the secant of theta is, well, the cosine of theta is the square root of 3 over 2, so the secant is 2 over the square root of 3. I can rationalize this, and it becomes 2 times the square root of 3 over 3. The reciprocal of the sine is the cosecant, and so if the sine is 1 over 2, the cosecant is 2 over 1, which is 2. And as far as the cotangent, it's going to be the reciprocal of 1 over the square root of 3, which is really just the square root of 3. So basically, that's how they work. Those words actually just refer to those points, which is why, of course, those points are very important. Let's say I'm looking at theta equals 5 pi over 4. So the first thing I have to do is I have to figure out what quadrant I'm in. First thing I do is change that to a mixed number. So what is that in a mixed number?
1/4 pi.
1 1/4 pi. Good. Which means it's more than 1, because here's 1 pi, and less than 2 pi. So we know it's in the bottom, right? And then we look and see, well, 1/4 is less than 1/2, which makes that point in quadrant 3. And then what is my reference angle?
1/4 pi.
Or pi over 4. Now, if you memorize this first quadrant, which I don't expect that anybody's memorized it as of this lecture. So this point here, which is pi over 4, which is the same as 45 degrees, is the square root of 2 over 2, comma, the square root of 2 over 2, which means that over here, what are my values going to be?
Yes. Negative square root of 2 over 2, negative square root of 2 over 2.
Exactly, because they're exactly the same size. except they're in quadrant 3, so both x and y are negative. So now if I want to evaluate the 6 trig functions, basically my cosine of theta is going to equal, well, my cosine is my x, so it's negative the square root of 2 over 2. My sine is my y, again, negative the square root of 2 over 2. My tangent, so here let me write x, y. My tangent is y over x, or sine over cosine. Since they're the same, is really just going to be 1. Negative square root of 2 over 2 over the negative square root of 2 over 2 is 1. So those are my 3 main ones. And then I have my secant, which is the reciprocal of my cosine. So I would have negative 2 over the square root of 2. And if I rationalize that, it becomes, it becomes negative the square root of 2. My cosecant is again the same thing. It's just the reciprocal of my sine. So again, it's going to be negative 2. And my cotangent is going to be the reciprocal of the tangent. The reciprocal of 1 is 1. So those are my 6 trig functions for 5 pi over 4. Okay, so let's say, for example, we're given that there's a point on the unit circle that is this value. And if I want to find all the trig functions, remember the cosine of theta is going to be x. My x value here is negative 7 over 25. My y value is sine, and that's 24 over 25. And the only way I can do this is if it says it's on the unit circle, which it says. And then I have my tangent, which is equal to y over x. So I have 24 over 25 over negative 7 over 25, which is going to equal 24 over negative 7. You can pull that negative out. So now that I have all my main functions, the reciprocal of cosine is secant, so I get negative 25 over 7. The reciprocal of sine is cosecant, which gives me 25 over 24. And my reciprocal of tangent is cotangent, which gives me negative 7 over 24. So that's not the exact problem that I wanted to give you, but I'm gonna actually do one of the ones I remember that people always struggle with. I'm gonna go here. I'm not gonna do this problem, but I'm gonna do another problem. Let's say I have a point. So I'm given a point 0.6 comma y, and I know it's on the unit circle. And I want to know, how do I find y?
Tangent?
Well, we can't because we don't know anything about tangent, right? So
Yeah.
what I'm going to do is I'm going to look here. I'm going to just put this on my circle. And it's not telling me what quadrant I'm in. So let's just assume we're in quadrant 1 here, quadrant 1. So, and here, let me draw a line. What I'm drawing here is this is 0.6 and this is y, right?
Oh, that's right, because it's 1. Okay, yeah. Mm-hmm.
And then we know that the hypotenuse, since it's on the unit circle, has got to be 1, right?
Mm-hmm. So then it's this hypotenuse over, or no?
No. Here, the only thing we can do here is use the Pythagorean theorem.
Oh.
You can say a squared plus, anytime you have a right triangle, that's the first thing you should think of. So we have a, we'll call a 0.6 squared plus b is y squared equals 1 squared. So I get 0.36 plus y squared equals 1. Y squared equals 1 minus 0.36, which is 0.64. Oh, that worked out well. So y squared equals 0.64, which means y is equal to 0.8. So now I know I could have a 0.6, 0.8.
Okay. Yeah.
So that made sense?
Yeah.
Very good. Let me see what this last problem is. I can tell you the answers in case anybody's curious. I want to find the value of t, so I'm actually looking for the angle. I know t is in quadrant 2 because it's telling me. And I know in quadrant 2, the x value is always negative. So if I want to know what the y value is that goes with that, it's going to be positive the square root of 2 over 2. So because I'm in quadrant 2, and I know that 45 degrees or pi over 4 is the matching value in quadrant 1, I know that's my reference angle. Pi over 4, or in degrees, it would be 45 degrees. So if I want to know what t is going to either be equal to 180 minus 45 or 135 degrees, or pi minus pi over 4, which is 3 pi over 4, right?
Mhm.
Okay, so I'm going to do B. If I'm not allowed to use a calculator, I only know certain points. I know I could have 1, 0 or 0, 1, right? 0, -1 or -1, 0. Those are the only points I can have on the axis. Or I can have 1/2 the square root of 3 over 2, or I can have them in reverse, right?
Mhm.
And that's basically those are the only points besides the square root of 2 over 2 and the square root of 2 over 2. Actually, I'm not even going to do any of the negatives, so I'm going to take all these negatives away. So these are the only real points that I have to memorize. Now we know that tangent is going to equal y over x. So I can pretty much eliminate right here those two because one's going to be undefined and one's going to be 0, right? If I put the y over x. And I can eliminate this right here because the square root of 2 over 2 over the square root of 2 over 2 is always going to equal 1. And my value is square root of 3, so it can't be 1. So I know it's one of those other two, obviously, because those both have the square root of 3 in them. One way to look at this is if I look at this like this, the square root of 3, let me put it over 1, because that's the same as the square root of 3. What I can do is say, well, notice they both have 2 as a denominator. So I can do that, can't I?
Yes.
And now I can see that my y value is going to be the square root of 3 over 2, and my x value is going to be 1/2. And if I draw a circle, and again, here my x value is smaller than my y value, which means it's got to be this taller angle in quadrant 1, doesn't it? Because the length of the x side of the triangle has to be smaller than the length of the y value. And I know that this actually goes to the 60 degree or pi over 3 angle. So that would be the answer. Just remember that you're only really having to work with these few numbers. Otherwise, you'd need a calculator. If none of those 5 numbers worked, you would need a calculator because that's all that we know by heart.